exercises are on page 297, 15 through 41 odd, 43, 44, 49, and 50. I think that's exactly what's on your syllabus. Before I start, though, I wanted to review a couple of topics. We went over yesterday. We said the axis of symmetry was x equal to negative b over 2a. We said the vertex is negative b over 2a, and then f of negative b over 2a. We said the y-intercept was 0 and c. And then we said that we would factor to find the x-intercept. So we would factor to find the x-intercept. So let's just go over or review factoring. So we have 4x squared plus 7x minus 2 is 0. So if we factor this, we would be looking for the factors of negative 8, and multiply together gives you negative 8, and add together gives you 7. So hopefully you would come up with 8 and negative 1. Remember, you've got to put 4 over each one of those. So 4 over 8 and 4 over negative 1. This cancels to 1 over 2. So our factors are x plus 2 and 4x minus 1. Okay. So those are the factors that we would have if we factored that quadratic equation. We went to the next step at the end of last quarter, and we set these factors equal to 0, x plus 2 is equal to 0, and 4x minus 1 is equal to 0. And we solved that to get x is equal to negative 2, and 4x is equal to 1, or x is equal to 1/4. These actually are what we call the x-intercepts of the equation. They're where the curve crosses the x-axis. So the x-intercepts are the solutions or roots. I have up here our 3 choices of solutions. The first is a picture of a parabola that sits on the x-axis. When it sits on the x-axis, it has one real double root. One real double root. It's called one real double because if you factor this equation, that is a parabola, you get x plus 5 times x plus 5. And you see where if you set this equal to 0, you're going to get the same answer. That's why it's called one real double root. Okay. The next picture I have, you'll see that the curve crosses the x-axis and intersects it in 2 places. In this case, we have 2 real roots. Those roots can be rational numbers or irrational numbers. The equation that I have here factors the x plus 2 times x plus 4. We get x plus 2 is equal to 0, and x plus 4 is equal to 0. So x is equal to negative 2, and x is equal to negative 4. So we see that that's where the curve crosses the x-axis. Those are the roots or solutions to the equation. They're also the x-intercepts. That's why it has 2 real roots. And lastly, we have up here a curve that never touches the x-axis. The equation for that is, or this particular problem, is x squared plus 2x plus 4. You'll notice here, if you you know, the factor, there are no factors of 4 when multiplied together to give you 4 and add together to give you 2. Now, without actually graphing it, you could not really look at this to tell me that the roots are imaginary, but because the curve never intersects the x-axis, it has 2 complex conjugate roots or 2 imaginary roots. It has the first graph where it sits on the x-axis, it has 1 real double root. When it crosses the x-axis and it intersects in 2 places, it has 2 real roots. Those roots can be rational numbers or irrational numbers. 2 real roots. 2, 3, 1, 2. And then lastly, it never intersects the x-axis, so it doesn't have any real roots. It only has 2 complex conjugate or 2 imaginary roots. Okay. So once again, I have written up here the axis of symmetry, x equals negative b over 2a, the vertex, negative b over 2a, negative b over 2a, y-intercept 0 over 2, and what we're going to do is find the x-intercept factor. The roots are the solutions of the quadratic equation. The zeros are the x-intercepts of the function. When a is a positive number, it faces up and has a minimum value. When a is a negative number, it faces down and has a maximum value. First example I have, you will need some graph paper for this. If it's in the form that's written up here, 8x minus x squared is equal to 16, the squared term needs to stay on the side of the equation that it is on because you're graphing it. So I would rearrange the order of this. Negative x squared plus 8x minus 16 is equal to 0. I would not move the squared term to the other side of the equation. You want to leave it where it is because it determines whether it faces up or down. Alright, so I know here that a is equal to negative 1, I know that b is equal to 8, and I know that c is equal to negative 16. So the axis of symmetry is x is equal to negative 8 divided by 2 times negative 1, so it's equal to 4. So x is equal to 4 is the axis of symmetry, so I'm going to draw a line on 4. The vertex, we're going to take 4 and we're going to plug it in the function. So if we plug it in, we get 4 squared plus 8 times 4 minus 16. So we get negative 16 plus 32 minus 16. So y is equal to 0. So we have 4 and 0. Y-intercept is 0 and negative 16. I think since I don't have a negative 16, I'm going to change mine up a little bit. We're going to make this constant base constant 16. negative 8, negative 16, negative 8, negative 16, positive 8, positive 16, and that means this would be 4. So we're going to move it around so we can fit this on our graph. It's okay, that's not the best, but it's okay. Alright, so once again we want to put our vertex at 4 and 0, and we know it faces down, and we have 0 and 16. The distance from here to here is the same, so we're going to put another point over here. The other thing we could do is just choose a point, like for instance, we might choose the number 2, okay, plug it in. We plug in 2, we get negative 4 plus 16 minus 16, so we get negative 4, and we have 2 and negative 4, which would be 2, 4, which is right here, here. We have a curve that looks like this. The domain is made up of all real numbers, and the range is y such that y is less than or equal to 0. It does have a maximum point. This is the maximum point as the face is down. The maximum value would be the y value of that curve, which in this case is 0. My next equation is x squared plus 6x plus 8 is equal to 0. The directions on tonight's homework are a little different from last night's homework. It says solve if the exact solutions cannot be found, state the consecutive integers between which the roots are located. We'll talk about what that means in a minute. So we know that A is equal to 1, we know that B is equal to 6, and we know that C is equal to 8. So we have x equal to negative b, so negative 6 over 2 times 1. So we have x equal to negative 3. Correct me if I'm wrong. The vertex, once again, we're going to take our negative 3 and we're going to plug it in the function. So we get y is equal to negative 3 squared plus 6 times negative 3 plus 8. So we get 9 plus negative 18 plus 8. So we get y is equal to negative 1. So we have negative 3, negative 3. So the y-intercept at 0, C is equal to 8. So we have 0 and 8. Once again, we know the distance from here to here is the same as to the other direction. So we're going to go 1, 2, 3 units in this direction. Y-intercept, got that. Now we're moving on to the x-intercept. Find the x-intercept, you've got to be able to factor this. So we're looking for the factors of 8. We multiply together, give us 8. We add together, give us 6. So x plus 4 times x plus 2 is 0. So x equal to negative 4 and x equal to negative 2. We have x equal to negative 4 and x equal to negative 2. We have a curve that looks like this. domain is made up of all real numbers. The range is y such that y is greater than or equal to -1. It has a minimum value at -1. They are x-intercepts, and so it's really -4 and 0 you're graphing, -2 and 0 you're graphing. The next equation, once again, I would rewrite this as x squared plus 2x plus 5 equals 0, a is equal to 1, b is equal to 2, c is equal to 5. Axis of symmetry, x is equal to -2 over 2 times 1, so x is equal to -1. The vertex is -1, and we're going to plug -1 in our function. We get -1 squared plus 2 times -1 plus 5. So y is equal to all that. So we have our 1 minus 2 plus 5. We get y is equal to 4. The y-intercept is 0 and 5. Whereas the factors, there are no factors. When multiplied together, gives you 5, and add together gives you 2. So they're not factors. So, our axis of symmetry is x is equal to -1. Our vertex is -1 and 4. Our y-intercept is 5. Let's put another point here. If you would like to plug a number in, we could plug in 1. We get 1 squared plus 2 times 1 plus 5. So what does that give us? 8. We have 1 and 8. We have our point here. Does our curve ever cross the x-axis? No. So we have two complex constant groups. The domain is all real numbers, and the range is y such that y is greater than or equal to what? I would like you to sort of get in the habit of it. We're going to have to do it down the road, but all right. So I put in x equal to -1. I plotted -1 up to 4. We plotted 0 and 5. You know there's another point opposite it. Then we plugged in a 1. We got 8. So we just plugged in 1 and got 8. So we plugged in 1 and got 8. I know the distance from here to here is the same, so that's why I went 2 over here. I would put a star by this problem number 4. is it says, if the exact solutions cannot be found, state the consecutive integers between which the roots are located. Are there any decimals or fractions in integers? No. So the first thing we need to do is subtract 1. The axis of symmetry, well, we know that A is equal to negative 1. We know that B is equal to 4. We know that C is equal to negative 1. So X is equal to negative 4 divided by 2 times negative 1. So we get that X is equal to 2. Draw our axis of symmetry on X is equal to 2. The vertex, we're going to take that number 2 and plug it in our function. So we have y is equal to negative 2 squared plus 4 times 2 minus 1. So we get negative 4 plus 8 minus 1. So we get 3. Does our curve face up or down? Faces down because A is a negative number. As A is a negative number, it faces down. So we have our vertex at 2 and 3. Y-intercept is 0 and C, so 0 and negative 1. We have 0 and negative 1. You notice there's another point on the opposite side, so we're just going to mark that. If we went to factor this, we would be looking for the factors of 1. Multiply together gives you 1, and add together gives you 4. Are there any such factors? No. No factors. Let's just choose a number and plug it in so that we have some numbers. So I'm going to choose the number 1. I'm going to plug it in. So I have negative 1 squared plus 4 times 1 minus 1. So I get negative 1 plus 4 minus 1. So I get 2. So I have 1 and 2, and I know I have another point here. So when I go to draw the graph, I have something that looks like that. These points are between numbers. So it is between 0 and 1, between 3 and 4. So when it says solve if the exact solutions cannot be found, state the consecutive integers between which the roots are located, that's what it means. The domain is made up of all real numbers, and the range is y such that y is less than or equal to 3. Then we would have found exact roots. Well, I think all the directions say this. The question is, which problem is it going to be between the numbers? I'd like to look at the calculator real quick because I want to show you something on your calculator that might be helpful. Okay, and it is something we're going to have to do later on, so I think we'll just go ahead and talk about it now. When we get to it later, it'll be easier. So on your calculator, the first thing I'm going to do is just go to mode check and make sure that everybody is on A plus BI. So make sure your calculator is on A plus BI. Right here, y'all. Alright, the next thing I'm going to do is go to Window. Oh, I want that. Go to Window and well, let's just go to Zoom and just go to these features. That puts it back on the default so that everybody looks the same. Okay, and I'm going to go up to y equals, and I want to put in this equation. So I'm going to take this one out. So I have negative x squared plus 4x minus 1, which is the equation that we have up here. Negative x squared plus 4x minus 1. Okay. Alright. So, when we graph this, we get a graph that looks like this, y'all. Okay. Let me see if I can make it a little bit bigger. So what we're trying to do is determine where these points are. Well, obviously, based on this graph, it's drawn a little bit better. You can see where the numbers are between 0 and 1, and between 3 and 4. My question to you is this. What happens to the y value when this curve crosses the x-axis? So the y value is what here? And what is it here? So the y value changes its sign when the curve crossed the x-axis or went through a root, right? Okay, good. What that means is this. Well, this is going from a positive to a negative. This went from a negative to a positive, right? Okay. So that's okay. Good question. So if you go to the second graph and choose the table, okay, everybody look up here. I'm going to stick the stuff over here. Does everybody see where on the table you're going from scroll up to get negative 1? Alright. Does everybody see that right here the sign goes from a negative number to a positive number? Does everybody see over here where it's between 0 and 1? 0 and 1? Okay, then down here, you see where it goes from 2 to negative 1? So you can see where you have a root between 3 and 4? Everybody see that? Okay. Alright, so that's what it means when it says that you cannot find the exact solutions, write the consecutive integers between, or whatever the direction is there, whatever you say. The consecutive integers between which the roots are located. Alright, that takes me to the last topic, which I'm going to have to race through, but we'll get to it again tomorrow. The next topic is called the sum of product rule. It's an extremely important rule. It's especially important for the ACT because it's a time saver. It's a huge time saver. The property says, or rule says, x squared minus the sum of x plus the product is equal to 0. So I don't know what tonight's homework says, but eventually we're going to be working problems that are like this. That if you are given the roots to an equation, you are asked to write the equation. tonight's homework, I don't think they label them. I think they negative 5 and 6 or something. I've labeled them root 1 and root 2, not that it really matters. If you are given the roots of a quadratic equation and asked to write the equation is x squared minus the sum of x plus the product is equal to 0. So x squared minus the sum of these two numbers times x plus the product of these two numbers equals 0. So the sum of these two numbers is what? 1. The product of these two numbers is 30, negative 30. So an equation that has those roots is x squared minus x minus 30 is equal to 0. Sum and product rule is used to write an equation given the roots. That's one way it's used. The other way it's used is if on the ACT it gave you the equation x squared minus x minus 30 and said, what's the product of the roots? What would you say? Negative 30. Negative 30. I mean, you could find the roots and then multiply them together. But it would be a waste of time. There's a little more to this problem than I've given you. We'll talk about a little bit more of it later. But let's go jump back here to some of these over here that all right. We said that some of these two numbers is 6. What's the product? 9 minus 4i squared. So 13 is the product. Right? So x squared minus 6x plus 13 equals 0 is an equation that has those for its roots. We'll talk about how to find those roots later, but anyway, so that would be an equation that had complex roots. If you graph this, it would never cross the x-axis. Well, we added these two to get 6. That's cool. Below these two to get 9 minus 4i squared is 13. Okay. Moving on to the next example. Got two roots up here. What's the sum of these two roots? 6 again. What's the product? 9 minus 2, which is 7. So the equation is x squared minus 6x plus 7 equals 0. Alright, so attempt the homework tonight, y'all, and I am going to put this on the internet, recorded along with the PDF file. So if you're having trouble, you might want to go back and watch it. You can stop it, play it back. There is a question about the sound that you'll just have to listen harder. I can't make the sound any better, or else I increase the file size tremendously, so I can't do that. I'd love to, but I can't. The product of these two numbers is 9 minus 2.